So in 8.1 yesterday, we talked about sequences in series, kind of like a broad introduction to sequences in series. In 8.2, we're going to talk about a specific type of sequence, which is an arithmetic sequence. An arithmetic sequence is when there is a common difference between terms. So it's when we're adding or subtracting the same number to get from one number to the next. So a example of an arithmetic sequence would be like 3, 5, 7, 9. What would our common difference be? What are we adding to get from one number to the next here? We're adding 2. So 2 would be our common difference. In example 1, it just gives us examples of arithmetic sequences. So I'm going to look down here, it gives us almost the answer and the question. But looking at the sequence 7, 11, 15, 19. So 4 is our common difference. On the next page, we're going to talk about a formula that we're going to use to help us come up with our sequence, the formula for our sequence. But since 4 is our common difference, that's what's going to get multiplied to n. That's kind of like our slope here. So that's what we add to get from one number to the next. Looking at B, what are we adding to get from 2 to -3, from -3 to -8, -8 to -13? We're adding -5 or subtracting 5, but -5 would be our common difference. So the sign is important. So we're subtracting 5 to get from one number to the next. That would be our slope in our equation. Looking at C, what are we adding to get from one number to the next here? It's a little bit harder to tell when it's fractions. It may be easier. Give everything a common denominator so we can see a little bit more clearly what we're adding. If I changed 1 to have a denominator of 4, that would be 4 over 4. And if I changed 3 over 2 to have a denominator of 4, this would be 6 over 4. So now let's think about it. What are we adding to get from one number to the next? 1/4. Awesome. So our common difference would be 1/4. Here was 7. Our second term is 11. Third is 15. Fourth is 19. What do you think I would have to do to find my 0th term? Subtract 4. So I would subtract 4. We would get 3. So notice how my equation here is 4, which is my common difference, times n, plus 3. So that's plus our 0th term. Let's do the same thing for B. So if my first term is 2, and I'm subtracting 5 to get from one term to the next, how would we find our 0 term? If we go backwards, what would we have to do? Add 5. Awesome. We do the opposite. So we would add 5. So our 0 term would be 7. So notice here that our a sub 0 is 7. And then we'd do the same thing for C. If I went backwards to find my 0 term, what would we need to do here? Subtract 1/4. So when we subtract 1/4, we'd get 3/4. So 3/4 would be our 0 term. So on the next page, we have our formula for an arithmetic sequence. When you are adding to get from one number to the next, we can come up with our equation for the sequence with this formula. So it is a sub n is equal to a sub 1. A sub 1 is going to be our first term. Plus n minus 1, so n is going to be the number of term, times d, which d is the common difference. That's what we're adding to get from one number to the next. Another way that we can write this formula which you can stick with this way every time. You'll have to simplify a little bit at the end. But another way that we can write this is a sub n is equal to a sub 0, or actually I'll call it d times n plus a sub 0. So we multiply our common difference by the nth term, and then we add the 0th term. So not the first term, but the term that would come before it. So you can solve these either way. You can come up with your equation. You can use this one, or if you like to go backwards and find your 0 term, you could use this one. You'll get the same answer. For example 2, it says find a formula for the nth term of an arithmetic sequence whose common difference is 3 and whose first term is 2. So it tells us a sub 1, our first term, is 2, and our common difference, d, is 3. Since it gives us a sub 1 and it gives us d, let's plug it into our equation here, our formula here. A sub n is equal to 2 plus n minus 1 times 3. And we can't just leave it like this. We want to simplify. Let's get it into kind of that y equals mx plus b form. Let's simplify. I'm going to distribute the 3 into my parentheses. A sub n is equal to 2 plus 3n minus 3. A sub n is equal to, what's 2 minus 3? Negative 1. So 3n minus 1 would be our formula. Typically, questions like this would ask us for our formula. They might also ask us for like the 100th term, let's say. If this asks us also for a sub 100 or the 100th term, what do you think I would need to do to find a sub 100? Awesome. I want to plug 100 into n. Looking for my 100th term. So I have this formula now to find whatever term I need to. I don't have to sit here and add the common difference each time. I don't need to sit here and keep adding 3. We can just plug in 100 into our formula. So we have 3 times 100 minus 1. So 3 times 100 would be 300, minus 1 would be 299. So that would be our 100th term. Example 3 is going to be a little bit tricky. These, I would say, are the hardest types of questions that you'll see from arithmetic sequence questions. So make sure you're paying attention to this. I'm going to start with my formula. I'm going to write that here. It is a sub n is equal to a sub 1 plus n minus 1 times d. Now it tells us our 4th term of the arithmetic sequence is 20. So a sub 4 is 20. And the 13th term is 65. So a sub 13 is 65. It asks us to write the first several terms of this sequence. So we need to figure out what our common difference is, bless you. And we also need to find the first several terms. So the first term, second term, third term of the sequence. But it gives us the 4th term and the 13th. So we're going to use what we have in the formula that we have. So we always want to start with the term that's farthest from the first term. So start with the farther term from 1. So here, which term would be farther from 1? A sub 4 or a sub 13? 13. So I'm going to say a sub 13 is equal to a sub 4. Now notice here, I'm just using this formula that I have. I'm using this equation. But in my equation here, it's n and 1. So I say n minus 1. In the formula that I'm using here, we're using 13 and 4. So when I plug my parentheses in here, when I plug the numbers into the parentheses, I'm going to say 13 minus 4. Do we notice the pattern? Instead of saying n minus 1 like I do here, We're saying 13 minus 4 times D. This formula is going to help us find our common difference. So we got to set it up this way to find what D is. We know what A sub 13 is. What's A sub 13? 65. So 65 is equal to, what's A sub 4? 20. Plus, what's 13 minus 4? 9 times D. So we're just solving for D here. Subtract 20 on both sides. We got 45 is equal to 9D, and then divide by 9. So this is 5 is equal to D. So 5 is our common difference. Next, we want to find our first term. So we're going to use this same formula, the same pattern that we just did, but we want to find A sub 1. So I could use either one of these here. I'm going to use A sub 4. So let's say A sub 4 is equal to A sub 1 plus, what would go into my parentheses here? 4 minus 1 now, perfect. Times D, and what do we say D is? 5. Awesome. And we know that A sub 4 is 20. So I'm going to plug 20 into here. So now we're solving for A sub 1, our first term. So here we have 20 is equal to A sub 1 plus 4 minus 1 is 3. And 3 times 5 would be 15. We can subtract 15 on both sides. So we got 5 is equal to A sub 1. So 5 is our first term. Bless you. So when it asked me to write the first several terms of this sequence, A sub 1 is equal to 5, what would A sub 2 be? How would we find A sub 2? We could plug in A sub 2 into our formula that we have now and find the second term. But what's our common difference? What's D? 5. So what am I adding to get from one number to the next now? 5. So what would A sub 2 be? Our second term? 10. What about A sub 3? 15. A sub 4 was given. That was 20. What about A sub 5? 25. We just add our common difference to get from one number to the next. Oops, this should be 25. So we're just adding 5, adding our common difference. So this would be the first several terms. So you want to use your formula. We have to find D first. Then you want to find your first term. Let's look at example 4. So we want to write the formula and find the 54th term of the sequence. So with our formula, what's our common difference? What are we adding to get from one number to the next? We're adding 7. Perfect. So 7 would be our common difference. We could use either one of our formulas. If we want to use A sub n is equal to A sub 1 plus n minus 1 times D, we could use this one, or we could try our other one. That's kind of a little shortcut. A sub n is equal to D times n plus A sub 0. We could use either one. Let's use our shortcut one. A sub n is equal to D times n plus A sub 0. So A sub n is equal to, what's D? 7. D is our common difference. So 7 times n. How would we find A sub 0? This is my first term, second term, third term, fourth term. How would we find our 0th term? Subtract 7. Awesome. When we subtract 7, what do we get? -5. So our 0th term would be -5. You would get that same answer if we were to plug in everything we have. A sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, our first term was 2, plus n minus 1 times 5. We would just have to distribute here. 5n minus 5. It's like, why is this not ending up the same? D was 7 here. So when we distribute 7, we get 7n minus 7. So a sub n is equal to 7n minus 5. We end up with the same thing. So you could do it either way. If you're not comfortable finding the 0th term, plug it into your formula and simplify. Next, it says find the 54th term. So we want to find a sub 54. What would we do to find our 54th term? What do we do? Plug in 54. Awesome. So we have 7 times 54 minus 5. So we're going to put this in our calculator. 7 times 54 minus 5 would give us 373. All right, so this is 8.2 part 2. So we left off on the sum of a finite arithmetic sequence. So it's the same notes as 8.2 that we did on Thursday. So when we find the sum of an arithmetic sequence, remember an arithmetic sequence is when we add to get from one term to the next. The sum is when we add up all of our terms together. So we have a formula for our sum of a finite arithmetic sequence. Finite meaning that it has an ending. So our formula for the sum is n over 2, where n is the number of terms, times a sub 1, which is our first term, plus a sub n, which is our last term. So let's look at example 5. It says find the sum of a finite arithmetic sequence. So we need to know the number of terms, we need to know what our first term is, and we need to know our last term. How many terms do I have here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So n would be 10. What's our first term? 1 would be our first term. What's our last term? 19. So let's plug that all into our formula. So our sum of our 10 terms is n over 2. So 10 over 2. Times a sub 1 plus a sub n, so 1 plus 19. So the sum of our 10 terms is 10 over 2, which is 5, times 20. So our sum would be 100. Let's look at example 6. So we're going to find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, 49. Dot, 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 meaning that it keeps going. Well, in order to find our partial sum, we need to find what n is equal to, so the number of terms, our first term, and our last term. How many terms does it expect us to add here? Find the what? What's the question asking us for? 150th partial sum. So we're adding up 150 terms. What's our first term? 5 would be our first term. Now, in order to find our last term, we need to find the 150th term. So we could just sit here and keep adding. What are we adding to get from one term to the next here? 11. We could just keep adding 11 150 times, but we'd be here all day. Let's tie in what we did in part 1 to help us find the 150th term. So to find a sub 150, I need to use my other formula, our formula to help us come up with that term. So we could either use a sub 1 plus n minus 1 times d, or we could use d times n plus a sub 0. What's d? What's our common difference? What are we adding to get from one number to the next? 11. So 11 would be d. I'm going to use this formula here. So 11 times n plus, if 5 is my first term, how would I find my 0 term? What would we do if we go backwards? Subtract 11. What's 5 minus 11? Negative 6. So this would be 11n minus 6. So to find our 150th term, we're going to plug in 150 into our formula here. So a sub 150 is equal to 11 times 150 minus 6. 11 times 150 would be 1,650 minus 6 would be 1,644. This is our 150th term. Why did I find this? What did we need it for? What is this? The last term. We needed it for our sum formula because it's asking us for the sum, but we needed to know the last term in order to plug it into the sum. So our last term was 1,644. That was our 150th term. Now we can plug it into our sum formula. So the sum of our 150 terms is equal to n over 2, so 150 over 2, times the first plus the last. So 5 plus 1,644. So S sub 150, or 150th sum, is equal to 150 divided by 2 is 75, times 5 plus 1,644 would be 1,649 times 75. We get 123,675. So that would be our sum.